So this ions, copper ions, actually this is a copper ion. So at anode reaction, at anode it will take place. Now you notice it, everybody. The copper ions are moving towards the what? Arrow. Arrow, you check it. They are moving towards the what?
Cathode.
Cathode. And the cathode is connected to the what? Negative charge or positive charge of the battery?
Negative charge.
Means it is electrons. So these copper ions, they will move towards to the copper ions, dissolved one. That is why aqueous state. So this copper ion state is also very important. But actually, have you seen that here? I mentioned. So copper is a solid, dissolved one is aqueous state. So this aqueous copper ions will go towards to the cathode and they will take again the 2 electrons and they will turn into the what? They will turn into the what? Copper or metal. So that's what it is. So anodic and cathodic reaction is most important one. For every metal refining, the same thing will happen. Just replace the metal symbol with M. And number of electrons, be careful. Okay. If it is mercury also, number of electrons, how many? 2 only. Understand? So like that, cathodic and anodic reactions is very important. So keep in mind, during electrolysis, cathode become thicker and anode become what? Anode become, yes please, thinner. Okay? So that is very important. So the size of the cathode is keep on increases and the size of the anode is keep on decreases because the soluble copper-like substances will dissolve in the electrolyte and they will go towards to the cathode so that the cathode size is keep on increases. And insoluble impurities, they will fall under the anode. That is only called as the insoluble impurities only we used to known as what? Everybody. Anode. That is what you have to remember it. So clear everyone? All of you? Yes? So that is why this diagram is very important. The same diagram I will be modifying for your purpose. So just to remember, what will happen? Instead of copper, I will put it as a Mn plus. Here also Mn plus. Is it Purima? What do you mean by Mn plus? M means what? Anybody? M means? Metal. Understanding? So metal, so that they are moving from anode to cathode. Anode to cathode. Is it okay, guys? All of you? Yes, please. So now you can see that. Always keep it in mind in refining of metals. Anode is actually impure metal and cathode is always what? Everybody? Pure metal. Okay? So that is what you have to take it. But cathode must be taken a very thin strip of pure metal so that the size of the cathode increases and the size of the anode is keep on decreases. Okay, guys? Mr. Guru, clear? Arun? Johan, no response. I don't know what these idiot fellows are doing. That's what it is. So this is what about extraction of least reactive metals. Whenever you get a low reactivity series, only 2 you have to remember. One is copper, another one is mercury. But equations are very important. Copper, again copper sulfide, cuprous sulfide is also reacting. And anodic reaction and cathodic reaction you have to remember very carefully. Cuprous sulfide. What is the Cu2 name as? Cuprous sulfide. Okay. So which is only we can say copper glans. Remember that names. Okay. So now directly they will get what? The oxides of these metals can be reduced to metals by heating alone. So the cinnabar and is an ore of mercury. When it is heated in air, it will be first converted into mercuric oxide. And then it will be reduced into what, guys? Reduced mercury and further heating. So that is why this one process, I can say, what we can put? Roasting is called as heating. Roasting and what is the second step? Everybody. Roasting or reduction. So this is roasting, this is reduction. This is roasting and this is reduction. So very, very important. Okay. So this is what about that. Only 2 examples you have. Learn the 2 examples. They will never ask more. Okay. Next. Extracting metals in the middle of the activity series. So in the middle of the activity series means what is that? Zinc. Yes, please. Next. Iron and lead. Copper is already over. We have considered. So only even lead you can leave it. If it is middle, only consider two examples. What is that? Zinc and everybody. Zinc and iron ore. That's all it is. Okay. So let us start with the zinc and iron. But here many steps are involving because they are moderately middle of the activity series. So that many steps. If it is a sulfide ore, you have to go for roasting. Then oxide of metal will come. Under that, you have to undergo the reduction with the coke and then only purifying metal. If it is the carbonate ore, go under the calcination. Oxide of metal will come. Then undergo reduction with what? Reduction with what? Everybody. Coke. And then you will get the purification of metal. Purima, ellame, understand ma? All of you? Yes? Everybody?
Sir.
That is
Yes,
what.
sir.
Please keep heading and write it next. Extraction of metals middle in the activity series. Extraction of metals middle in the activity series. Extraction of metals in the what? Middle in the activity series. So for this, what are the examples? Mind immediately should say, one is zinc, another one is what?
Iron.
Iron. No other metals. Okay. Take these only two examples. So zinc and iron are the examples of moderately reactive metals, and they will find in two kinds. Anybody can tell me? Both zinc and iron can be found in. Yes, please. They will be found as what? They found as sulfide ores and as well as what? Carbonate.
Carbonate ores.
So if it is sulfide ores, we have to undergo what? Roasting or calcination?
Roasting.
Roasting. If it is a carbonate ore, we have to undergo what? Everybody?
Calcination.
Yes, that is what is I wanted. So calcination. Calcination means what? Presence of oxygen or absence of oxygen?
Absence of oxygen.
Absence of oxygen.
Roasting means presence of oxygen. Already when I give for roasting and calcination example, I have given you zinc carbonate and lead carbonate. Same way zinc sulfide and lead sulfide. Am I right or wrong? Everybody? Check it everyone. I have given or not? Yes, please. Check your notes and let me know. For calcination, conversion of the ore into oxides. That is what calcination, I have given zinc carbonate plus lead carbonate, both reactions. And roasting, zinc sulfide plus lead sulfide, both reactions I have given. Am I right, Harish?
Yes, sir.
Yeah. So let us see now. We'll finish this one. So as they are present, both sulfide and carbonate ores. So they cannot be reduced directly. So first step, what we have to do it? If it is sulfide ores and if it is sulfide and carbonate ores, they cannot be reduced directly. So cannot be reduced directly. So only what is the way? First thing, they have to be converted into what? They are converted into what, guys? By roasting or calcination. What is the use? Converted into what? Into oxides. Understanding? Oxides by the process of what? By the process of roasting or calcination. Okay. So by process of roasting or calcination, we must convert them into oxides. And then oxides, what will happen? Undergoes what reaction? By using reducing agent, guys. By using reducing agent, that is what? Coke. That is what is the process we used to say? Reduction or oxidation?
Reduction.
Reduction. That is what? It will be reduced. Reduced to metal by what? By using a coke. That is what we can say. What is that? Either carbon or one more metal also we can use it. I told you. Either carbon or
Aluminum.
we can use aluminum. But your class 10th, they will use only what? Yes, please.
Carbon.
Carbon. That alone you have to remember it. Okay. So let us go with conversion of carbonate and sulfide ores into oxides. Step number 1. Conversion of carbonate and sulfide ores into oxides. Conversion of carbonate and sulfide ores into oxides. Okay. So make it. So what is the first thing? First, conversion of carbonate. So what is the process? Carbonate means calcination or roasting, everybody. Calcination. Am I right or wrong? So calcination. So calcination means, let me take first zinc carbonate. What is the zinc carbonate formula, everybody? ZnCO3. What is the common name? Common name, tell me. Calamine. Understand? So which is equals to, it will gives you zinc oxide plus carbon dioxide. Okay, I got it. Then sulfide ores, tell me. Zinc sulfide. What is the name of the zinc sulfide? Anybody? Zinc sulfide name. Very bad. 3 days before I have given you the tabular column. Zinc blend, it is in the presence of oxygen. So this is called as what? Roasting or calcination? Who is to called as roasting. So undergoes zinc oxide plus we are going to get sulfur dioxide. Mr. Pugal, are you there? Can you tell me the balancing equation, Pugal? Both. I think it is already balanced. This one balance equation, tell me, Tami. Fastly. Everybody. How many times we written? Again, I am asking also same. Respond and tell me, what is the balanced equation? 2 ZnS will react with the 3 O2 gives you 2 zinc oxide plus 2 SO2. Am I right, guys? All of you?
Yes, sir.
Yeah. Please proceed. Make it quick. That's what it is. Now, reduction of metal oxides into... Who is that fellow, Ra? Jiviteze. Hey, Jiviteze. Always disturbance only. Focus on work, boy. Next, second step, tell me, Ra. First step is over. Converting carbonate and sulfide ores into oxides. We converted zinc carbonate into zinc oxide, zinc sulfide into zinc oxide. What is the next step? Fastly. What is that? Reduction. You should speak. That is what. So reduction of metal oxide. Metal oxide into what, guys? Everyone. Reduction of metal oxides into metals. So that's all. So by using what? Reduction process will take place what? By using what?
Carbon.
Carbon. So reduction by carbon. So carbon we will take in the form of what?
Coke.
In the form of coke. So coke is the allotropy of carbon. Keep it in mind. So what is the reaction will take place? Zinc oxide reacting with the carbon. So which will heat. If you undergo the heat, we will get directly zinc plus carbon monoxide. Okay. So now this carbon monoxide further be used as a reducing agent. The produced CO can be further used as reducing agent because carbon monoxide is very dangerous. Am I right or wrong? Everybody. Yes, please. So again, the zinc oxide, if undergoes carbon monoxide gas, if you have started heating, so again we will get a pure zinc plus instead of carbon monoxide. By this time we will get what, guys? Carbon. Yes, carbon dioxide. So combine these two equations. So we'll get overall equation. What is the overall equation? Anybody? Overall reaction. This is very important. So zinc oxide, 2 zinc oxide reacting with the carbon. That is what coke will give us Zn, 2Zn plus CO2. So this is the overall reaction. If you are capable, you can learn both equations and then third one. If not, at least learn the third one. So that is what is my suggestion. So you must learn, but actually every equation is very important. So keep it in mind. All the equations are very, very important. But still, if you are not finding, you can simply go with that. Okay. So at least last one. So that is why it will be displacement reactions also can be used here. So what is the displacement reactions only we are using here? So just it is replacing that zinc oxide turning into zinc, like zinc is replaced by carbon. So even if people don't know correct metal activity series, even the carbon is also present. If you notice 11th class, 12th class, you will get it. So 12th class, if you go, metal activity series, carbon is also included. Carbon is also more reactive one. Understanding? Here we removed hydrogen. Please never call me a zebra. I like hydrogen is gone because hydrogen is not included here. I like hydrogen. Call me a mercury. Mercury is also missing here. Call me a girl or gold. Gold means here silver. So even some metal activity series, 12th class, if you go, carbon is also present. So if you notice it, carbon is even more reactive than what? According to this equation, carbon is more reactive than what? Anybody?
Zinc.
Zinc. So that is, you have to remember it. Understanding? So that is why they mentioned here, all of you remember, they never give the equations. Simply see that. Besides using carbon to reduce metal oxides to metal, sometimes displacement reactions can also be used. So for extraction. So because displacement reactions, what will happen? We all people knows that. If you want to get a pure metal, displacement reaction, more reactive metal displaces the less reactive metal. That is why I said, instead of coke, we also can use another thing. Anybody can tell me? Yes, please. Aluminium. Aluminium for what purpose? Anybody can tell? For what reactions? Everybody.
Please.
For what reactions, guys? Hey, Jivitesh, what is this nonsense? Don't have sense at all. Get out from the meeting, man. You understand, everybody? Why we need to use aluminium? All of you remember, aluminium instead of by using carbon, understanding, for reduction process, instead of that we undergoes what reaction, guys? If you want to get a zinc, we undergoes displacement reaction also. Understanding? That is why I said instead of coke, also we can use it what? Basically. Yes, please. Aluminium. Of course, here they are mentioning sodium and calcium also. Why I will prefer aluminium? Anybody can tell? Why can't sodium and calcium can be? Why I will prefer aluminium instead of sodium and calcium? Anyone? Yes, please. Nobody. Because sodium and calcium are more reactive metals. If I use sodium for separating zinc, it may be explodes also. Am I right or wrong? It will produce a lot of heat energy. Of course, if you want, you can use it. Nothing wrong in that. But always we can use it. This also for displacement reaction. Aluminium. Aluminium is very preferred because it will be normally reacted. But aluminium is more reactive than zinc or not? Everybody? Yes, please. Aluminium is more reactive than iron or not? Aluminium is more reactive than manganese. Am I right or wrong, everybody? Yes, please. Please respond. So that is why these kind of metals, aluminium, zinc, manganese and all, we can also undergo the displacement reaction for extracting, and we can use them as a reducing agent. Who is the reducing agent? Sodium, calcium and aluminium. So by the time they can displace metal of low reactivity from their compounds. So that is what manganese dioxide is heated with the aluminium powder. So this is what following reaction will take place. And iron oxide is heated with aluminium. This is what the reaction will take place. So these both are highly exothermic reactions. These are only called as what reactions we used to call? Everybody. Yes,
Thermite
please.
reaction.
Thermite welding. Thermite welding or thermite reactions. The most important one. That is why I said instead of coke, either coke for reduction reaction, either coke or we can use it what, guys? We can use it aluminium. Why aluminium I use it? Do you understand, everybody now? All of you? So aluminium can be displaced because it will be more reactive than displacement reaction will take place. Understand, Abhirami, Mitakshri? So this is what extremely important one, and it is highly exothermic reaction. Even in our sample paper, this equation came. Do you all remember, everybody? Yes. So that is what you have to remember it. So instead of carbon, that is what coke, we can use it as a display highly reactive metals also as a reducing agent. So, but by the time that reactions are extremely exothermic, so even compared to the sodium, the most preferred one is aluminum. So that is what even railway trackings, you can notice it here, thermite process for joining the railway tracks. So this is what is used process. Okay, for joining thermite welding, extremely highly exothermic process. So from here, we'll continue in the next class. So please all of you make it. Then we are going to study extraction of metals towards the top of the reactivity series. So top means simply simple process. What is the simple process? We'll get directly pure metals by what process? Simply, I already told you, by electrolytic process. Understanding? So top metals. Top metals means what is the examples? Anybody? Sodium, magnesium, calcium, aluminum. Sodium, potassium, calcium, magnesium, aluminum. So these all are simply by electrolytic process, we people obtain the, yes please, obtain the pure metals. That's all it is. So you can see highly reactive metals just by electrolyting of molten ore. What do you mean by molten? Anybody can tell? Molten means what? Yes, please. Liquid. Liquid state.
Liquid.
So directly we will get pure metal. That's all it is. That process we will discuss in our tomorrow's class. Now today's class, what you studied is extremely important. So reacting with a carbon, for zinc alone I taught you. Iron I will teach you tomorrow. Your book is having only zinc and iron also we will study. So iron, once we study, and then this reactions is extremely important because as iron is also present here, we need to know iron. Am I right or wrong, everybody? So iron is reacting with aluminum. That is what thermite welding, we can say. Okay. So that both reactions also we will discuss and we'll make a, so overall reactions and we'll proceed. Okay. So thank you, everybody. With this, I'll stop and we'll continue in the tomorrow's class. So please, all of you go through that and learn it. Each equation is very, very tough in this chapter. So please kindly practice once, even 10 times you write and practice is always preferred because your mind will remember balanced equation more easy when you are writing, reading and writing. That is the only request to you people. So kindly follow up. Okay. So thank you, everybody. We'll meet in tomorrow's class.
Thank you, sir. Bye, sir.